Hello, math enthusiasts. Welcome to Invalid Proof, the channel where we dive deep into the fascinating world of mathematics. I'm MC, your guide into this numerical journey. Well, not very numerical, but we'll see. So today we have a very interesting question about trigonometry. So we have a bunch of triangles here and some information that's given to us, but what we want is to calculate the length of AC, which is here, and I name it X to be easier to follow. And so AB would be our X, and well, we will take a look at this. So let's see what it has given us and what it wants from us. So let's take a look. So AB is equal to AC, which is X, and this is the same, X. BD equals to BE. This is BD, I call it Y, and this is BE, I call it Y as well. They're the same. And CE and BC. This is CE and this is BC. Look, we have this and this. Okay, so this is 9, and I just put 9 on it. I don't name it because it has a number. So, and since this is 9 and we have CD at 5, CD is equals to 5, so this would give us ED equals to 4, and BC is 9, which you can see on the screen, and what we want is this. So uh, what I want to do here is that I want to break down these triangles to see what I can get from them, but how are we gonna do that? I mean, let's see. This big triangle ABC that we have, it's isosceles triangle. It has two equal sides, x here, with the information given to us. The same thing, we have the same thing for the middle triangle, BCE. You see, this is 9, and this is 9 as well. And also, we have the same thing for this triangle, BDE, two sides with the same length. So I will separate these three triangles to see what I can get from them. So we have this, right? And what is cool about this is that all of them are isosceles triangles, and it gives us a very interesting information. In these triangles, these angles have the same size, right? Let's use 3 for this, okay? And it's cool, right? But how are we going to use this? Like, um, how is it going to help us? Okay, let's see. So this angle B in the ABC is here, okay, right? It's the same in the middle triangle. It's the same, see? So since these are the same, I can use I can use another indicator for them. I use this, right? Let's give it a name, okay? So this is B, and this would be B as well. So since this is equal to this one, this would be B as well. And this is equal to this one, so this would be as well. And there is one more thing here. Let's take a look at this angle, E, right? For the smaller triangle, it would be this, right? But for the middle triangle, it would be this. So they are equal as well. So this would be the same as the other triangle B, and this will be the same. So they all have the same angles. So, but the question is, how is this gonna help us? Well, it reminds me of a semantic concept, similar triangles. Let's take a look. So, what are similar triangles? Well, similar triangles or similar shapes, they have the same shape but different sizes, right? But how are we going to use this? So similar triangles have the same corresponding angles, so their angles are the same, and this is more important. Their corresponding sides have the same ratio. They are not exactly the same, but they have the same ratio. What it means is that, first of all, these angles are the same. So if this is y as well. This is x as well. And this is z as well. So they have the same angles. But corresponding sides having the same ratio, it means that if the c side is corresponding to R side and the rest, and you can see the rest, we will have C on R equals to A on P and finally B on Q. And this is going to help us calculate, find the answer and calculate the length of AC in our question. So, but how are we going to know if two triangles are similar if we don't have, if we don't know everything about them? So there are a few ways to test for similarity. Okay, the first way that we can test for similarity is equality of two corresponding angles. So if two angles in two triangles are the same, then we can deduct that the two triangles are in fact similar. For example, let's say in these two triangles we don't know anything. We just know that this A equals to this B, okay? And let's say this is C and this is D. C equals to D, okay? And this is enough for us to deduct that these two triangles are similar, and it results in this quality. If we know that two corresponding angles are in fact the same, we can use this ratio to calculate whatever we want. So this is one way. The other way for testing for similarity is as if three corresponding sides having the same ratio. Okay, so in the first one, we know about the angles and we can use this ratio. But in the second way, it's the other way around. We know about the ratio and we can deduct that the angles are the same. There is another way to test for similarity, which is two sides with the same ratio and their in between angle having the same size. So, which means, for example, this angle should be the same as this angle, and this side, for example, A prime, B, and B prime. A and A prime and B and B prime should have the same ratio, and their angle A should be equals to B. And that way we can deduct that these two triangles having the same are similar, and we can use the rest of the information that it gives us. Anyways, doesn't really matter. We are going to use something very much easier than that. So let's go. So let's go back to the question and let's take a look at our triangles. Okay. Well, let's go further. Okay. This is the information that has been given to us. Okay. I want to rename these triangles so that I don't have to use this A, B, and this kind of stuff. So what I'm going to use is to use another color first of all, because it's cool. I call this X, which is our target. This would be the same based on the information. And let's call this Y. This would be Y as well. And okay, here's the thing. So we have this, okay, and this is 9, right? This is 9. And this is 9 as well. And this is 9 as well because this is BC, this is the same side, okay? Also, we calculated that ED is 4. You can go back, okay? CD was 9 and EC was 9, CD was 5, so BD was 4. Okay, and EB, this is Y as well. Okay, now, here's what's interesting. First of all, why are these uh, triangles similar? Here's why. This is B and this is E. These two angles are the same because this triangle is isosceles and B is equal to B. This is the same angle, so they are the same. They have the same size. So we can see that in this triangle, since this one is also an isosceles triangle, B is equal to C. Now, see these two triangles, how two equal corresponding angles, which makes it obvious that these two are similar. This we can do the same thing for this triangle. See, this E angle is the same here, and this is equals to this D because this is isosceles triangle. Now you can see that they have the same angles, so they are similar. Now that we know they are similar, we can write down the ratios and calculate it. So for ABC triangle and C, let's say BCE, the big one and the middle one. For here, we can write down x on 9 equals to 9 to y. See, x 9 and this 9 to this y. So that's one. Also, for these two triangles, we can, for ABC and BDE, which is our smallest triangle, we can write down x on the y equals to 9 on 4, right? 9 on 4, x and y. And finally, for the final triangle, uh, this time we get middle one and a smaller one, BCE triangle and BD, right? Okay. Here, this is the best part, okay? So 9 on y equals to y on 4. This 9 to this y and this y to this 4. Wow. Okay, we only have one variable. We can just calculate it like this. So y to the power of 2 equals to 9 times 4, which gives us y equals to 3 times 2 and it's 6. Okay, we found y. It's amazing, great. Okay, but that's not what we want. We want x. Alright, we should color back? No, we should calculate it. Alright, so I can, put the amount of y on to any of these and just calculate it. Let's do this one. Okay, let's do this one. So we have x on the 6 equals to 9 on the 4, and let's come back here. Let's go here, x to 6, 9 to 4. We can do this again, and well, x equals to 6 times 9 on 4. Okay, here's how I calculate this without any sort of calculator, I take this and say this is 3 on 2. Well, you can easily see it, and this is 1.5, right? There's no problems here. Okay, and 1.5 times 9 gives us this 9 plus 4.5. This is the one part, and this is the half part, right? Half and 9. And it gives us 13.5, which is easily calculated. These kind of tips and tricks, you can use them to calculate all sort of stuff in mathematics without any calculator or anything. That's amazing. There are a lot of these kind of things, and we will use them in future videos, of course. And this is it. We calculated the length of AC, which was what we wanted using a very basic concept in mathematics called similar triangle. I hope it was clear enough. However, if you have any questions, just let me know in the comments and I will be reading them. And if you found this helpful, give it a thumbs up and share it with your friends. Thanks for watching and catch you in the next one.